Good morning, students. My name is Mara Gadno. I'm a physics teacher. Today I teach you lesson 5, unit 6, lights. So I start unit 6, lights. What is lights? Light is an electromagnetic wave which emitted from a hot body. So the light is emitted from a hot body, and light produces sensation of human eye, sensation of our eyes or human eye. And we see the colors, all colors depends on the lights, and also to produce lights, some other form of energy have to be converted to light energy. For example, in an electric lamp, electrical energy is changed to heat and light energy. And the other is optics. Optics is the branch of physics which studies the nature, property, the nature and properties of light, So optics is a branch of physics which studies the nature and property of all lights. And the other use of light, vision and visibility, and visibilities. And the other, it helps to plants to make food, and to grow. And the other, the energy of light from the sun can be gain solar energy. Solar energy. And also it is used in power station. So the uses of lights are vision and visibilities, make a food to grow and gain solar energy from sunlight, and the other is to use a power station. And also sources of lights. Light have a source, so the sources of lights are bodies which generate and emit light energy of their own. So these bodies are called luminous bodies. These luminous bodies generate light by their own. For example, the sun is generate heat by their own, and fire, burning candle, and burning lamp and burning candles. So these are a source of light. This source of light is called luminous bodies. These luminous bodies is called generate light energy by their own. And most bodies do not generate light of their own. It's called luminous bodies. These luminous bodies does not generate light energy by their own. For example, a wall a person, a tree, a book, and also the moon, the mountain, and stones. These are illuminous bodies. These illuminous bodies does not generate heat by their own. So the difference between luminous body and illuminous bodies are luminous bodies generate light by their, and also illuminous body that does not generate light. So the difference is luminous body generate light. Illuminous bodies does not generate light by their own. So the difference is this. And we can classify the source of light as natural source of light and artificial source of light. The natural source of lights includes the sun, stars, electricity in a storm, fireflies, jellyfish, and mushrooms. These are natural source of lights. In this, fireflies and jellyfishes are animals, but mushroom is also plants. So plants and animals are also the source of light. And the next is artificial source of light. This artificial source of light includes candle lamp, match, incandescent lamp, and halogen lamp, and also fluorescent lamps. This is artificial source of light, and also this is natural source of light. The next is how does light travels? How does light travels? Light travels in slow in a medium, slow in a medium, slow in a medium, slow in a medium, but fast in a vacuum. Fast in a vacuum. So the difference is slow in a medium but fast in a vacuum. And the other, individual light waves always move a straight line. Individual light waves always move in a straight line. Just like this is individual light rays. This is individual light rays. Always moves in a straight line. And the other, the direction of the path followed, the direction of the path followed by the light is called a ray. This is a ray represented by a straight line with an arrow. We can make this is a ray. So the direction of the path followed by the light is called a ray, and it is represented by a straight line with an arrow. And the other is beams of lights. A directional propagation of light energy radiating from a light source is called a beam of lights. And also sunlight forms a light beam. It's called sunbeam. Sunlight forms a light beam. A light beam, or is called sunbeam. Sunbeam. And a group of rays of light is called a beam of light. A group of rays, just like this. This is a group of rays. A group of rays of light is called a beam of light. So this is a group of rays travels in parallel. So this is a group of rays is called a beam of light. And the next is there are three types of beam of light. Beam of light. These are the first parallel beam. In a parallel beam, when a large number of rays travel parallel to each other, for example, we can make this is a group of rays goes parallel beam is when a large number of rays travel parallel to each other, These rays goes parallel each other. Then we call the collection of the rays is called parallel beam of lights. These are one of the parallel beam. And the next is diverging beam. The diverging beam is also when the ray of light starts from a point, and travel in various or different directions. Then the direction of the collection of such rays are called diverging beam. For example, this is a point. From this point, the rays travel in this direction and also this direction. This is the starting point. Then from this starting point, the rays goes different directions or various directions. It is called diverging beam. This is the example of diverging beam. Diverging beam. So this is in the point, starting point. From this starting point, the rays goes in different directions. So the diverging beam is this, and also the third is converging beam. The converging beam is the way the ray comes from different direction, different directions, which finally meet at a specific point. This specific point is called a focus. For example, the rays comes from this direction and this is converging beam. This is focus. So this rays comes from different direction, and meets one specific point. This specific point is called focus. So then the collection of this converging beam is called converging beam. And the next is kinds of light transmission. There are three kinds of light transmission. The first is transparent material. Transparent materials are passes light completely. But very little light is reflected or absorbed by the material. For example, clear glass and clear water clear plastic, clear plastic. These are transparent materials. Clear glass, clear water, clean plastic. These three materials are passes a complete light. So this is transparent material. And the next is translucent. Translucent materials. Translucent materials that allows only some light to pass through. Passes some light, or half light, half, passes half lights. In translucent material, light passes through, but objects on the other side can't be seen clearly. For example, tin fabrics, frosted glass, and also tin or oiled paper, tin or oiled paper. These are translucent materials. And the third is opaque material. Opaque materials are do not allow or do not pass light through. Some of the light is absorbed by the material and some is reflected. Does not pass a light. Does not pass a light. Absorbed by the material. Absorbed by the materials or reflected on the light reflects on the material. For example, metal, thick paper, trees, stones, aluminum foil, wood, building, etc. There are so many opaque materials. And the next is reflection of lights. Reflection of light is the turning back or bouncing of light rays. When it encounters a different medium. And other, when light rays hit an opaque material, it totally reflects, because opaque materials does not pass a light. And also light is travel in all direction from a source. And this propagation of light is represented by ray of light. Kinds of reflection. There are two kinds of reflection: regular reflection and diffused or irregular reflection. Regular reflection is a reflection from a regular shining in a smooth surface. This is a smooth surface. Or all reflections are parallel to each other. This is an incident ray. Incident rays. And also this is a reflected rays. In regular reflection, the incident rays and reflected rays are parallel to each other. So incident rays strikes on this material and reflectors to this direction. So this is regular reflection because the material is smooth and shining. And the next is diffused reflection or irregular reflection. Irregular reflection. Diffused reflection is a reflection from irregular and rough surface. The surface is not smooth. This is a regular rough surface. So in irregular reflection, the incidence ray I and reflection ray R is not parallel. Not parallel. The incidence ray strikes on the mirror or the smooth surface. It reflects different direction. In diffused reflection, the incidence rays are parallel, but the reflected rays are not parallel. The incidence ray strikes parallelly, but not parallel reflection. So the incidence ray is parallel, but the reflection ray is not parallel. And the reflection ray are not parallel to each other. The next is types of rays. There are two types of rays. These rays are the incidence rays and reflected rays. These rays are we can sign this is O, this is a mirror or a reflecting surface. We can say this M, and this we can sign A, B, and N, and also this angle I, R, and we can sign this alpha and beta. So there are two types of rays, incidence ray and reflected rays. Incidence rays and reflected rays. So let's see one by one. The incidence, this is incidence rays, incident ray. This is a reflected array, and this is normal. Let's see one by one. M is plane surface or mirror. Plane surface or mirror. A plane surface or mirror. And AO is source of incident ray, source of incident ray. The ray comes from this direction and strikes on this mirror and reflectors to this direction is called the reflected rays. So OB is called reflected ray. OB is reflected ray. And also NO is perpendicular to the mirror, the plane surface or the mirror. It makes 90 degree. Is called normal. this is an imaginary line. This is a normal imaginary line. And also O is point of incidence, point of incidence. The incident rays strikes on this surface or in this mirror. So this O is point of incidence. And also the angle between incidence rays, we can say I. The angle between I and normal is called angle of incidence. Angle of incidence. So this is angle of incidence. Angle of incidence. Angle of incidence I. And the angle between the angle between normal or reflected ray, we can say I, R, and normal is called angle of reflection. Angle of reflection. So this is angle of reflection. Angle of reflection. Angle of reflection. So the angle between incident ray and normal is angle of incidence, and the angle between reflected ray and normal is called angle of reflection. Angle of reflection. So next, the law of reflection. The law of reflection. This law of reflection, the angle of incident is equal to the angle of reflection. The angle of incident is equal to the angle of reflection. For example, this is an angle of incident ray. This is normal. This is reflected ray. So this is I, angle of incidence, and R, angle of reflection. So the law of reflection says, 1, the angle of incidence I, is equals to the angle of reflection, R. For example, the angle of incidence I is equals to 40 degree. The angle of reflection must be 40 degree, because angle of reflection is equal to angle of incidence. So this is one law of angle of reflection. And the next is the incidence ray. Second law is incidence. The incident ray and reflected ray. Reflected ray is the sum of angle of incidence and angle of reflection. That means I plus R. This is the second law. The third law is the incident ray, reflected ray, and normal to the reflecting surface at the point of incidence all lies in the same plane. For example, this is the plane or mirror. Third law. For example, this is a mirror or plane surface. This is incident ray, incident ray, also reflected ray, plane mirror, and also normal. All are lies on the plane mirror, on the same mirror, on the same plane. So the third law is this. Example 1. The part of the reflection of light, the reflection of light from a mirror are labeled on this figure. What do the letters stand or write the name? For example, A, B, C, alpha and beta. So A is what? Incident ray. Ray. B, reflected rays. The incident ray strikes on this surface and reflected in this direction. So B is reflected ray. C, normal is perpendicular to plane mirror, and also it makes 90 degree normal. Alpha, angle of incidence, and beta is angle of reflection. And the second example is a ray of light strikes on a reflecting surface at an angle of 40 degree from the normal. Required A, draw the diagram. The diagram is this. We can make the diagram. The diagram is this. The arrow is this. Normal. This is reflected ray. This is also incident ray. So a ray of light strikes a reflecting surface at an angle of 40 degree from the normal is, this is an angle of incidence. So the given is I is 40 degree. I and R. So find the angle of reflection. By the law of reflection, I is equals to R. So I is 40 degree. R is also 40 degree. So R is 40 degree. This is B. C. Find the angle between the reflected ray and the mirror. The angle between the reflected ray and the mirror. This we can take this alpha. Alpha plus R is equals to 90 degree. The angle between normal and okay. So alpha plus 40 is equals to 90 degree. Alpha is equals to 90 degree minus 40 degree. So alpha is equals to 50 degree. So the answer is 50 degree. The angle between the reflected ray and the mirror is 50 degree. Example 3. Okay. Please, student, please try this question. Example 3. A ray of light strikes the surface of a mirror at an angle of 25 degree. Draw the diagram and incident ray, reflected ray. ዛሬ የነበረን ትምህርት ይህን ይመስላል። አመሰግናለሁ።